Use of the Opuntia ficus-indica as a coagulant for wastewater treatment. Greetings to all, welcome to our presentation. We are Bernardo, Landa, Regina, Sánchez, and me, José Pablo, Castelazo, and being team IBBC19, we will be talking about a solution to a major inequality, which is the lack of access to clean water. According to the WHO, globally, 1 out of 3 people are not able to reach safe drinking water. Moreover, in Mexico, there are over 1 million liters of residual water produced every 4 seconds, of which 80% is not treated. Due to the need for a viable solution, we decided to make an investigation on whether a natural coagulant could be as efficient as a chemical one. For this, we created a quadruple E proposal, which consists in evaluating the environmental compatibility, the ethical responsibility it yields, the economic benefits for its users, and to determine whether its efficacy is acceptable or not. The noble mucilage is a mixture of polysaccharides and a fibrous substance, supporting a scientific theory made by Monroy Galicia and Salgado Lopez in 2019 in El Salvador. It was selected due to being the most viable and potential contender.
Because of this, the objectives were proposed so the problematic could be faced from a broad number of scopes. Firstly, both coagulants were contrasted to identify which would be the most eco-friendly. Likewise, after the analysis of results, the aluminum sulfate samples would be tested to find pollutants, and the possibility of mass-producing nopal mucilage as a coagulant would be determined.
The hypothesis consisted in proposing that using nopal mucilage during the coagulation process for wastewater treatment would result in the turbidity decreasing and the other parameters being similar or even better in the samples, in contrast to a conventional chemical coagulant, thus forming an easily treatable and environmentally friendly sludge. With regard to the methodology, it was divided into 2 sections. The first one consisted in the mucilage extraction from nopal cladode. After being weighed, disinfected, and brushed, the tissue was macerated in purified water for 24 hours at 16 degrees Celsius, while subsequently being stored in a conventional refrigerator. Once done, the first filtration occurred. Following that, the supernatant was placed in a 1-liter beaker and subjected to a 75 degrees Celsius water bath for a day. This led to the mucilage precipitation from aqueous phase being carried out by adding ethanol in a 1:3 ratio. Lastly, the mucilage precipitate was obtained from a second filtration. As it can be seen on the screen, the following video sums up the nopal transformation process, all the way from being a cactus plant to obtaining the mucilage. On the other hand, after a 5-liter water recollectation from the Polanco Canal, Mexico City, measurements for the pH, dissolved oxygen, electrical conductivity, and turbidity were performed with a variety of sensors. In sequence, 3 samples were treated with 10 milliliters per liter of aluminum sulfate prepared at 10%, and 3 with 0.5 grams of mucilage. All 6 were stirred until floc formation occurred. Accordingly, their measurements were taken.
Regarding the results and permitted parameters, which were considered according to the Mexican and Latin American standards. Furthermore, as it can be seen on the screen, the results were classified depending on whether they achieved or failed this. Satisfactorily, the nopal mucilage seems to be the most efficient. Complementing the aforementioned, a few charts which evaluate the coagulant's results are observed. First of all, the mucilage pH came out perfectly, while the aluminum sulfates reduced horribly. Secondly, the oxygen levels presented a low result for the mucilage. Howbeit, it is expected to improve by adding more mucilage to the samples.
All conductivity levels are inside the standards, yet the results from the aluminum sulfate raise questions regarding its effectiveness. Now, even though the mucilage turbidity did not reach the minimum requirements, it is thought that enlarging its quantity will permit it. As for the comparison amongst them, the nopal mucilage was identified as extremely more beneficial. This was not only due to being around 1.42 times cheaper, but also because there was no waste generated, has many beneficial effects on the human scalp, is eco-friendly, and it can purify up to 200 liters of water with just 1 kilogram of mucilage. Lastly, the limitations seen were the lack of financial capacity, the COVID-19 pandemic disruption in the trialing, and some uncertainty about the adequate quantities of mucilage needed.
Aside from the previous statements, there were a few conclusions that can sum up the experiment. Firstly, even though the hypothesis was partially accepted due to the mucilage turbidity result, the main objective was successful, as both coagulants were identified. Then, due to the limitations, the presence of pollutants on the aluminum sulfate samples was assumed, but not confirmed. The possibility of mass-producing the mucilage to function as a coagulant was widely demonstrated, thus meaning the experiment's overall result was extremely successful. Finally, the use of the nopal mucilage represents a circular economy process, beneficial for Mexican low-income communities. Likewise, it was identified that wastewater presents an incredible option as a future ecological energy source. As for further investigation, a trial expansion to determine the exact amount of mucilage needed for a better result will be made, to be able to prove its safety.
So what do you say? There will always be problems, but the change must be made now. The change is called nopal mucilage. Thank you very much for your time. Here are the references consulted.